Hi everyone. Here question is conversion of NFA to DFA using subset method. Along with this question, NFA state transition table is provided. So to convert this NFA to DFA, what we will do first, we will convert this NFA table to DFA state transition table, and from the DFA state transition table we will draw the diagram for DFA. So let's start. How we can convert this NFA table to DFA table? We can follow the process of subset construction. For example, column headers are as it is, like here 0 and 1. The first row will be as it is. While making it as it is, suppose P is a starting state. Subset method says that, for example here, P on reading 0 going to P comma Q. Why there is a P comma Q? Because it's a NFA. Non-deterministic. Non-deterministic property says that by reading the one symbol, one state can go to more than one state. Here P on reading 0 going to P, or it can go to Q also. This is what non-deterministic property. But deterministic property says that by reading one symbol, one state will go to only one state. Hence, subset method says that, for example here, P on reading 0, if it is going to P comma Q, I will write here PQ, and here P comma Q in the NFA, but in the DFA it will be PQ and it will be one subset. One subset means what? This PQ will be considered as only one state, like this in diagram notation. Here in NFA these are the two states P comma Q, but in the DFA it is only one state. So P on reading 0 going to PQ. Similarly on reading 1 it's going to P. So as per the subset notation, square bracket P. This square bracket notation is optional here. Then on reading 0 P is going to PQ, and on reading 1 it's going to P. So new subsets are created, or I can say new states are created are PQ, because P is already covered here. So take the new subset or new state PQ. So I'm writing here PQ. Now PQ reading 0. Check the NFA table. We are deriving DFA table with the help of NFA table. So PQ reading 0. So here is a P, here is a Q. Even though in the DFA table PQ is a one state, but in the NFA table P and Q, these are the new separate two states. Not new, these are the two separate states. If we want to find out PQ reading 0, then take the P row as well as Q row on reading 0. So P reading 0 going to PQ, Q reading 0 going to R. So combine this. P reading 0, P comma Q, Q reading 0, R. So combine this PQ R. So I am writing here P, Q, R, and this is a new subset. Even though in the NFA table PQR are the three states, but in the DFA table it will be only one state, that is a one subset. If I draw in terms of notation like this PQR, this is the only one state. Similarly PQ on reading 1, so P on reading 1 going to P, Q on reading 1 going to R. So combine this PR. So I'm combining this P, R. So here new subsets are created. For example, PQR is a new subset, PR is also new subset. So take one by one. So I'm taking first PQR. Then I will take PR. New subset means what? PQ and P, these are the old one. PQR is not covered, PR is not covered. So I have taken this new subset. Now repeat the process. Here PQR is a one state in the DFA table, but in the NFA table PQR, three states. PQR on reading 0. How to find this notation? Refer the NFA table. P on 0 going to PQ, Q on 0 going to R, R on 0 going to S. So you have to consider all this PQRS. So these are the three values that you need to consider on reading 0 from PQR. So what are these values? P comma Q comma R comma S. So PQRS. So I am writing here PQRS. If you are thinking why this so, as non-deterministic property PQ are different states, I have combined this. it should go to only one state, so I'm combining all these states of zero transition. PQRS. Similarly, this PQR on reading 1, where it's going, that we need to combine. P on 1 going to P, Q on 1 going to R on going to null, nowhere. We can combine this. PR 5, 5 means nothing, so PR only. So PR, this is the one subset. What are the new subsets or states of DFA here? PQRS. So I'm writing here PQRS. PR is also new, but PR is already taken here, so no need to take it again. So next state or next subset PR on transition 0. How to find it out? See, PR. So here is a P. P on 0, where it's going? It's going to PQ. And similarly, R on 0, where it's going? It's going to S. PR. So P, it's going to PQ on 0. R, it's going to S. So combine this S and PQ. So it becomes PQS. So PQS. This is one more subset. Similarly, for 1, PR on 1, P on 1, it's going to P. R on 1, it's going to phi. So P phi is nothing but P only. Is there a new subset? Yes, PQS is a new subset. P is covered here. We started with P only. So PQS is a new subset. So PQS. Now repeat the process for PQRS. PQRS means here is the one state in DFA, but in NFA, these are the different state. PQRS. PQRS on 0. So PQRS on 0 means what? Addition of first column. PQRS. So all the states in NFA, these are the different states, but in DFA it's only one state. Subset notation, square bracket. Similarly, PQRS on 1, all this PRS. So PRS. Is there any new subset or state created? PQRS is covered here. PRS, no, it's not covered. So PRS here as it is. So PQRS is completed. Now PQS. Repeat the same process. How to design for PQS? You can follow the same process. Here PQS is the one state on reading 0. So P on reading 0, PQ. Next is Q, R. Next is S, yes. PQS. So I am concentrating on this P for 0th column, Q for 0th column, S for 0th column. Combine this PQRS. So it's going to PQRS. Similarly, for transition 1, P on 1, P, Q on 1, R, S on 1, yes. So PRS. Is there a new subset? PQRS covered here. PRS already written, so no need to worry, no new subset. Next one is PRS. Repeat the process for PRS also. PRS on transition 0. So check in the NFA table how we can find out this. Here is a PRS. So P on transition 0, PQ. R on transition 0, yes. S on transition 0, yes. So combine this PQ, then yes. PQ, yes. This is a subset. Similarly for 1, PRS on 1, P on 1, P. R on 1, phi, S on 1, yes. So PS. Is there a new subset? Check. PQS is covered here itself. PS is covered? No. So PS will be new one. So write down this PS. PS on 0. So how to find it out? Refer the NFA table. What does NFA table says? P on 0, PQ. S on 0, yes. So PQS. So write down here PQS. Then PS on 1, P. S on 1, yes. So again it's a PS. Combine it. So PS. Is there any new subset here? PQS is the old one as it is. PS is covered here. So no new subset. And all these are DFA states, or I can say DFA state transition table. Starting state is P itself. What is the final state? In the NFA table, we have given yes as a final state. So as I explained in the last video, in all the DFA state, wherever is a yes, that state becomes the final state. Here yes, no. Where is the yes? Yeah, here is the yes. So this state becomes the final state. PQS, this also becomes the final state as it contains yes. PRS contains yes, becomes final state. PS becomes yes, so becomes final state. So 1, 2, 3, 4, 4 are the final state. Now from this state transition table, we can easily draw the diagram. If you don't know how to draw the diagram from the table, you can refer the one of the previous video where I have explained with example how to convert table to diagram or diagram to table. You can refer it and we can draw the table from this, you can draw the diagram from this table. We will see one more example how to convert NFA to DFA. Thank you for watching.